Okay, so we are starting exponentials, and in exponentials we have exponent laws, exponents review, solving exponential equations part 1 and 2, and then we also have exponential applications. But this is just going to be a quick review on exponent laws. As you can see here, I have a huge chart here, and this is x to the power of 1, x to the power of 2, x to the power of 3, and so on and so forth. So let's begin. Okay, so we have to review our exponent laws. So we have product of powers, meaning if there's two expressions with the same base, meaning the same number, and they both have different exponents, we then add those exponents together. Then we have quotient of powers, meaning two expressions with the same base, meaning the same number, and we're dividing, and then we take those exponents and then we subtract them. And this is just another way to put it, or this is what this will look like. Then we have power of a power, meaning that if it's in brackets and there's m and n, we then multiply those exponents together. And then we have power of a product, meaning that if there's two bases and it's in brackets with an exponent, that exponent is applied to both bases. We have power of a quotient, which is similar. So we have a fraction here, or division, and then we have it's in brackets multiplied by the exponent m. That exponent is expanded to both bases on the top and the bottom, with the restriction of b cannot equal 0. And then we have our zero law. So at any base, or any number with the exponent of 0 is equal to 1. And then we have our negative exponent law. So if we have a negative exponent, we usually tend to work with negative exponents. We like to get them out of the equation. So just taking the reciprocal, and this is quite self-explanatory. We take that base, we move it to the bottom, and then the exponent becomes positive. But if it's already on the bottom and it's negative, then we can move it to the top, and then the exponent will be positive. We also have the rational exponent law. So if your exponent is a fraction, we're looking for the n root of a brackets multiplied by or to the exponent of m. Okay, going back to my pen. So in this question we have 2 as a common base. Using product of powers, the first exponent law, we add the exponents together to get a final answer. So equals 2, 4 plus 3 is 2 to the power of 7. And then we have, we need to use the quotient of power exponent law. Bases are the same, meaning we can subtract the exponents using exponent law number 2 to get a final answer. We use power of a power law, the third exponent law. We multiply the exponents to get a final answer of 2 to the power of 12. So 2 . We use the exponent law number 1, called product of powers. We have the same base, so we add the exponents together. this is using the first exponent law, which is product of powers, and then F uses quotient of powers. We have the same base of 2, and it's just making sure we have the correct operation within the exponent. Obviously, we can't solve for m because we don't know what m is, but 2 to the power of 3 plus m is the correct answer. And then with F, it is divided. There's division, so it's quotient of powers, and just so we have the same base, and the base is the 2, so we just need the correct operation. So it's 2 to the power of 7 minus y, and again, we can't solve for y, but that's what the final answer is. Okay, so we have division there, so it's quotient of powers, 2 to the power of x minus 4, because there's division and we subtract the exponents when there's division. For h, we are going to use exponent law number 3, power of a power. We multiply the exponents together. We don't know what x or y is, but we know that it's multiplied together, so that's our final answer, 2 to the power of x multiplied by y. And then for I, we have 2 to the negative 3 times 2 to the power of 4. So because the bases are the same, the bases are both 2, we go ahead and we add those exponents together, so negative 3 plus 4 would be 2 to the power of 1, which is just 2. Okay, so again, it's division, so quotient of powers. Okay, so again, it's division in letter J. There's division, so we subtract these exponents because they both have the same base, the base of 2. So we have negative 2, subtract negative 5. These two cancel out, and it becomes a plus sign. So it's like negative 2 plus 5, because there's 2 negatives there. It's 2 negative cancels out and become positive. So it's negative 2 plus 5, which results in 2 to the power of 3. Okay, so for k, we have the third exponent law, which is power of a power. We have and 2 exponents, there's brackets in between, meaning that we multiply the exponents together. So 2 to the power of 3 times negative 1, and that leads to 2 to the power of negative 3, and then again we bring it down to the bottom of the denominator, and just to make sure that the exponent is left in a positive result. Power exponent law number 3, multiply the exponents together. The exponent is negative. We don't usually leave the answer with the negative exponent in math due to the negative exponent law, law number 7. Moving on. So again, we have the same base and it's multiplied together, so we're using exponent law number 1. Power, product of powers, and then we are adding the exponents together, so it's 2 to the power of negative 4, and again we don't really leave negatives in the negative. We don't usually leave exponents negative, so we're going to use our negative exponent law, and it becomes 1 over 2 to the power of 4. We have We have bases that are the same, and multiplication, meaning we add the exponents using exponent law number 1, product of powers. We add -4 and 0, and then use the exponent law number 7, the negative exponent law, to get a final answer with no negative exponents. And again, our final answer is 1 over 2 to the power of 4. And now we're going to move on. Evaluate to solve for. So we are not going to leave these answers in exponents. We're going to solve them. So first we have our negative exponent law number 7. Then we have 3 to the power of 2, which calculates to 9, with our final answer being 1 over 9. Using the 0 law, any base to the power of 0 is calculated to be 1. So we have a negative exponent. So use the negative exponent law, and then 1 over -2 to the power of 4. And then we have a negative number to the power of 4. So if it's to the power of an odd number, the answer will be negative. If it's to the power of an even number, the answer will be positive. Evaluate -2 to the power of 4 to get a final answer of 1 over 16. 2 to the power of 4 is 16, but it's also a negative number, so basically it's 1 over -2, -2, -2, -2. So -2 times -2 is positive 4. Positive 4 times 2 would be times -2 would be -8. -8 times -2 is positive 16. So just to clarify, if it's to the power of an odd number, the answer will be negative. Just like if it was -2 to the power of 3, it would be -8. But in this case, it's -2 to the power of 4, meaning it's going to be positive 16. And again, if it's to the power of an odd number, the answer will be negative. And if it's to the power of an even number, the answer will be positive. So here's our answer. Okay, so we have power of a power exponent law number 3. For D, so 2, -1 times 2, 2 to the power of -2, 1 over 2 to 2, 1 over 4. So we have power of a power exponent law number 3, so we multiply the exponents together to get 2 to the power of -1 times 2. We then have to use the negative exponent law, and then so we use the negative exponent law number 7. Then we evaluate 2 to the power of 2 to get a final answer of 1 over 4. So we have to use the 0 law for letter E. Any base or number to the power of 0 is 1. So 1. We then have a negative symbol to expand for a final answer of -1. So we use the negative exponent law because when we have any base, any base with a negative exponent must be moved to the denominator to get positive exponent. So any base with a negative exponent must be moved to the denominator to get to switch the exponent to be positive. But if it's already on the denominator, then we switch it towards the numerator, and then we have a positive exponent. So 5 to the power of 2 is 25. Circle it. So we use the negative exponent law, moving 5 to the power of negative 2 up to the numerator to make the exponent positive. And then we evaluate 5 to the power of 2 to get a final answer of 25. So we use the negative exponent law, moving negative 4 to the power of negative 1 to the numerator to make the exponent positive, meaning it would be negative 4 to the power of 1. And then we solve for a final answer. Negative 4 to the power of 1 is just negative 4. Moving on. So we have exponent law number 3, I believe, power of a power. So we have a negative symbol, and then we have 3 times negative 2, meaning we have negative 2 to the power of negative 6. Then we have negative 1 over 2 to the power of 6. And negative 1 over 64, because 2 to the power of 6 is 64. So we have exponent law number 3, power of a power. We multiply the exponents together. We have a negative exponent result, so the negative exponent law moves 2 to the power of negative 6 to the denominator to get a positive exponent. Then we solve 2 to the power of 6 on the denominator, and keep the negative symbol as well, so it's negative 1 over 64. Moving on. Express each answer with a positive exponent. So we have A, using exponent law number 1, we add the exponents together. So we have A to the power of 7. Okay, this is another way to show multiplication. They're just in brackets, and it's multiplication. So we have m to the power of 6 plus 2. We add the exponent when there's multiplying with the same bases, and we have m to the power of 8. Moving on, we have multiplication. All bases are the same, so it's b, b, b. And so we're going to add these exponents together. So we have b to the power of 5, b to the power of 6, and b to the power of 1. 5 plus 6 plus 1 would be b to the power of 12. Okay, so we have different bases, but I see a common base of a, so 1 plus 4 using our first exponent law. Product of powers when there's multiplication between when there's multiplication and the bases are the same, we add the exponents together. And then we have b to the power of 2 there. So we have a to the power of 5 times b to the power of 2, and that's our final answer. Okay, and then we have another way to show multiplication is just when there's brackets around each mathematical expression, but I see commonalities. So we have the common base of x, and we have the common base of y. So we have x, 3 plus 5, and then we have y, 1 plus 4. So x would be to the power of 8, and then y would be to the power of 5. Yep, moving on. Okay, so we have common bases here. It's just multiplication, so we have x, 3 plus negative 5. And if you jam those numbers into your calculator, you will get -2. But we can't have a negative exponent, so we use our negative exponent law, and we are left with 1 over x to the power of 2. And then we have exponent law number 1, so there's multiplication, so with the same basis, so we're going to add those exponents. -4 plus -5. We have m to the -9, and then we use our negative exponent law, so it's 1 over m to the power of 9, and that is our answer. Moving on, we now have h, and I believe that all bases are the same. So we're going to add these exponents together. So -1 plus -3 plus 2. So -1 and -3 is -4. And then we add 2, which is y to the -2. And then we use our negative exponent law, so it's 1 over y to the it's 1 over y to the power of 2, because we used our negative exponent law. This was -4 plus 2, resulting in -2. And then we have our negative exponent law, moving it down to the denominator to make the exponent positive, because if you recall, it says express each answer with a positive exponent. So we're going to be using the negative exponent law quite a bit. Moving on. So we have the same bases, which means we're adding the exponent. 5 plus 0 is still 5, so we have a to the power of 5. We have the common base of a. Meaning that we are going to add these exponents together, because it's just another way to show multiplication if things are in brackets. And then we're going to multiply b to the -2, but I realized that b is a negative exponent, so we might be moving it to the denominator to make it a positive exponent. So we have a to the -3 and a to the power of 2. Adding -3 plus 2 would be -1 times b to -2, and we will be moving both a and b to the bottom. 1 over a, b, 2. Alrighty, so it's 1 over a, b to the power of 2. Moving on. Simplify, express each answer with a positive exponent. So we have coefficients here, so 5 and 3 multiply together to be 15. It is multiplication, so we're going to use exponent law number 1, which is product of powers. Let's see. Yep, product of powers. So we have m, 4. So the basis of m, the coefficients multiplied together equal 15, and then we add these exponents together, so 4 plus 2 equals 15m to the power of 6, and that's our final answer. And then we have coefficients of 4 and -5, which would be -20, and then we have a, and then we have b. So a to the power of 1 and a to the power of 3, so 1 plus 3, and then we have b, and b is to the power of 4 and to the power of 2, so 4 plus 2, and then we have -20 in front again, because we multiplied the coefficients, so a to the power of 4 and b to the power of 6. And that's our final answer. Okay, so if we go down here, we have 3 expressions, so 5, -2, and -6. So -2 multiplied by -3 is +6. So 6 times 5 equals 30. And then we have a to the power of 1 and a to the power of 1 as well. So a 1 plus 1. And then we have b to the power of 2 and b to the power of 3. And again, it's multiplication. So we add these exponents together, so it results in 30, a to the power of 2, b to the power of 5. Yep. Okay, moving on. We have question D. So we are going to multiply -6 and -4 together to get +24. And then we have m to the power of 3 and m to the power of 1. And we have n to the power of 2 and n to the power of 5. Meaning we have 24, m to the power of 4, n to the power of 7. There you go. And that's our final answer. Moving on, we have bases. We have a common base of x, and we're going to be adding those exponents together. And then we have the coefficient of 7 and 6. So 7 multiplied by 6 equals 42. And we have x2 plus -2. So we add these exponents together. It's 2 plus -2. So that cancels out. Actually, I'm going to do it in red. That cancels out. It's now 42 x to the power of 0. 42 using our 0 exponent law equals 1. And we are left with the answer of 42. Moving on. So we have coefficients of 3 and -2. So it's going to be -6. Then we have common base of x and common base of y. So x is to the power of -2 plus 2. And then y is to the power of 2 plus -3. So we have -6. -2 plus 2 cancel out. It equals 0, x to the power of 0. And then y to the power of 2 plus -3 would be -1. So we have -6, and using our 0 law, that becomes a 1, and using our negative exponent law, we move y to the denominator to make the exponent of -1 positive, and then we have -6 over y. Yep, there you go. Moving on, we have coefficients of -6 and -1, so it results in +6. We have multiplication here with the common bases of a and b. So we're going to add the exponents, so -1 plus -3, and then we have b to the power of 2 plus -4. So we have 6 to the a, 6 multiplied by a to the power of -4, and then b to the power of -2. So we're going to use our negative exponent law. 6 will be left on the numerator, a will be brought down, and so will b, meaning that we have a final answer of 6 over a to the power of 4, b to the power of 2. And we will circle that and leave that there. Next, we have division. So if it helps, you can write it like this: -10x to the power of 4 over -2x to the power of 1. Negatives cancel out. Negative over negative cancels out. So 10 divided by 2 would be 5. And we have x to the power of 4, subtract 1. So we have 5x to the power of 3, and that's our final answer. Moving on. So we have 45 over 9, meaning 45 divided by 9 would be 5. We have a to the power of 2, subtract a to the power of 1. So we're going to subtract those exponents. And then we have b to the power of 4, and we're going to subtract 2. Because whenever there's division, we subtract the exponents. So that's what we're going to do. So it's 5, a to the power of 1, b to the power of 2, meaning 5ab to the power of 2. And that's our final answer. Moving on. So we have multiplication within our numerator, and then we're going to deal with the denominator and subtract our exponents and divide if necessary. So 4 times 7 is 28. We have m as a common base and n as a common base, and we're going to add those exponents. So m to the power of 2, m to the power of 3 becomes m to the power of 2 plus 3. And then we have a common base of n. So it's going to be 4 plus 1 over 14m n to the power of 5. So we have 28m to the power of 5 n to the power of 5 over 14m n to the power of 5. So 28 divided by 14 equals 2. We have subtraction here because quotient of powers, meaning whenever there's division, we subtract the exponents. So 5 minus 1, and then n is 5 minus 5, and then we have 2m to the power of 4, n to the power of 0, 2m to the power of 4, n to the power of 0 becomes 1 because of our 0 law, so it's 2m to the power of 4. I'm going to rewrite that. 2m to the power of 4. All right. Sounds good. Moving on. So 35 divided by 5 would be 7. And then we have x to the power of 5 and x to the negative 3. So we have a common base of x using the exponent law number 2. Whenever there's division, we subtract the exponents. So x to the power of 5 and x to the power of negative 3. So we're going to subtract negative 3. As I said before, 2 negatives cancel out. And it would be 7x 5 plus 3. So 7x to the power of 8. Sounds good. Let's keep going. So we have negative 6 here. So negative 6 divided by 2 would be negative 3. And then we have exponents here that we need to subtract because exponent law number 2, there's division. So we're going to subtract these exponents. 4 minus negative 1 and n2 minus negative 6. Again, 2 negatives cancel out and become positive, so we're going to scratch those out. Negative 3, m, 4 plus 1, n, 2 plus 6. So we have negative 3, m to the power of 5, and n to the power of 8. And then okay, moving on. Sorry, just double checking my work there. Alrighty. So